Hello everyone. In a previous video we made nitrobenzene. We'll be using the nitrobenzene we made in this video to make aniline. Both nitrobenzene and aniline are suspected carcinogens, so be careful when handling. Start by weighing out 120 grams of iron powder. I may do another video later using tin, but iron powder just happened to be what I had in the lab right now. Followed by 140 milliliters of distilled water, and then 15 milliliters of 31% hydrochloric acid. I'm just using pool muriatic acid. Now in a fume hood or outside, place a sturdy stand with a clamp attached. Then set a lab jack under the clamp. On top of that, place a hot plate. Now clamp in a 1 liter 3-neck round bottom flask. Place it so that it is gently resting on the hot plate. To the flask, add in the iron powder and then the water. Now place a thermometer and then an overhead mixer. This is one time when the overhead mixer is not optional. Mixing is very important if you want any kind of yield at all. You can't use a magnetic stir since iron is one of the reagents. Last, you'll need to add an addition funnel with 82 milliliters of nitrobenzene. I have to use an extension to get around the motor for mine. Here's a quick pan so you can see how it all goes together. Now start the mixer and pull out the thermometer. Slowly add the hydrochloric acid. We need a way for pressure to escape this apparatus since we'll be heating it. So when you replace the thermometer, replace it very loosely so that any trapped gases or buildup of pressure can escape. Turn on the heat to your hot plate and add about 5 milliliters of nitrobenzene. The mixture will begin a light gray, but will go to a dark black after a few minutes. Heat the mixture with a hot plate to about 80 degrees C. Once you reach that temperature, remove the hot plate. Now add an additional 3 to 4 milliliters of nitrobenzene. You'll notice the temperature starting to rise after a few seconds. You want to maintain a temperature between 80 to 90 degrees C. If it gets hot, you'll need to cool with a water bath. When the temperature starts to drop, add more nitrobenzene. It took me about an hour to add all the nitrobenzene. Once it's all been added, set it for reflux and gently reflux for 30 minutes. After the 30 minutes, turn off the heat and remove the flask from the heating mantle. Allow the mixture to cool to room temperature. Now, slowly add 20 grams of potassium carbonate while mixing if possible. Once all the carbonate has been added, we can now steam distill. Steam distillation is very simple. You'll just need a container to boil water and a way to route the steam into your flask. You can see how I did it here with a retort, a hose, a glass rod, and a stopper. The glass rod goes all the way down to the bottom of the boiling flask. The rest of the setup is just simple distillation. After setting up, turn on the heat to your steam generator, and after some time it will begin to produce steam that will enter into the reaction flask and distill over the crude aniline. A turbid distillate can be seen coming over. You'll need to continue to distill until the distillate goes clear, as you can see here. When it goes clear, turn off the heat and remove the stopper from your steam generator so that a vacuum doesn't form. Place what you collected in a large set funnel. You can see that the aniline is currently the bottom layer. Now add 100 grams of sodium chloride and shake vigorously until all the salt dissolves. Then place a sep in a ring stand or clamp it in and let the two layers form. You may notice that the aniline is now the top layer. This is because the salt changed the density of the water. Let it stand for 20 minutes and then remove the bottom layer and discard. Place the top layer and some boiling chips in a suitable boiling flask and set up for simple distillation to remove the water. Turn on the heat and keep a close eye on the temperature. It will climb to 100 degrees C, then hold until all the water distills over. Then you'll see it start to quickly increase. When it reaches 130 degrees C, turn off the heat and let it come to room temperature. Once cooled, disassemble the distillation apparatus, setting the flask of aniline aside. Wash all the other parts with water and acetone. Then use a heat gun to remove any residual moisture. When everything is dry, reset up for simple distillation and again turn on the heat. The aniline distills over at 180 degrees C, leaving behind any impurities. When it was finished distilling, I was able to collect 56 milliliters of aniline. Take whatever you got and place it in an amber, airtight bottle and store out of direct light. Aniline slowly oxidizes in air, so aged samples have a dark brown color. Not a problem, you can just redistill it. We'll be using what we made here in future videos. I found this procedure on Science Madness posted by a very talented chemist, so I can't really take credit for it other than to say that it works, and I appreciate the time the person spent putting it together. Thanks for watching this video, and I'll see you in the next one.